Good day, welcome back to my channel. Today we'll be factorizing trinomials, our third installment in factorizing trinomials. Now, when we factorize trinomials with mixed terms, for instance, suppose you are to factorize a trinomial such as this. Now we are looking at our third example. So we have 9a plus 3a squared plus 6. Now clearly in this instance we are given an expression, but now this expression is not placed in the right sequence, so we need to write it in a descending order or descending form. So what we need to do is to have 2 as the highest degree in our first term, so we have 3a squared. So notice we have 2 as the power there, and then plus 9a as our second term, and then lastly we have 6 as our constant. Now that we have written this in descending order, our next application is to ensure that we look at with analysis, we can clearly see that it's a common factor right across. We can divide this by 3. In this case, if we divide by 3 here, and we divide by 3 here, and we divide by 3 here, we have 3 as a common factor. So 3 and 3 will cancel out. We have a squared plus, so 3 into 3 enters once, 3 into 9 enters 3 times. So we have 3a, 3 into 3 enters once, 3 into 6 enters twice, plus 2, close bracket. Okay, now 3 is our factor, or a common factor in this case. So moving forward, what we need to do now is to maintain our 3 as a common factor and then have our parenthesis. So we have a multiplied by a, and then the common factors of 2 are 2 and 1, and the leading or bigger value between 2 and 1 is 2. I focus on 2 now, and then the operation in front of the middle term is positive, and then the bigger value takes the operation in front of the middle term. So in this case it's positive, this positive here. So positive multiplied by positive gives us positive. So in a nutshell, that is our answer. So we have 3 multiplied by a plus 2 multiplied by a plus 1. Let's look at our next example. Our next example, still on third installment. So we have 9a plus 3a squared plus 6, writing in descending form. We have 3a squared plus 9a plus 6. Okay, so by multiplication or cross multiplication, we know that 3a multiplied by a gives us 3a squared. So we have 3a multiplied by a gives us 3a squared as a leading coefficient or leading term in this expression. So when I want 2 terms, or 2 factors rather, after multiplying them, they must give me a certain product. Okay, now the product of after multiplying that should give me the sum of the middle term. So in this case, what I need to do is to multiply 3a multiplied by positive 2. Remember, this is positive. And a multiplied by positive 3. So let's multiply this up. So 3a multiplied by 2 gives us 6a. A multiplied by positive 3 gives us, remember this is positive, a multiplied by positive 3 gives us positive 3a. Now notice, after adding, it's very important that we add these two products. After adding those two products, they must give me the sum of this value there, which is positive 9a. So positive 3a plus positive 6a gives us positive 9a. If this is true, then we can start taking our, or rather collecting our, grouping our factors. So we have that first parenthesis and then a second parenthesis, which means therefore that 3a plus 3 is multiplied by a plus 2 is equals to 9a plus 3a squared plus 6, of which is when written in the correct format should give us 3a squared plus 9a plus 6. The third installment for today, we have question 3. So in this case, still given the same problem. So in this case, we write it in the descending order. We have 3a squared plus 9a plus 6. It's very important to write this in descending order so that you're able to execute the values, the signs, and the numbers successfully. Okay, so now by multiplication, I need to multiply my leading coefficient. The value of the leading coefficient in this case is 3, multiplied by the constant, which is 6. So after multiplying these two values, in other words, I'm multiplying these two values. 3 multiplied by 6 gives me 18. Okay. Now, I need to find two factors of 18. Those two factors of 18 are positive 6 and positive 3. So I prefer to write this in brackets, and positive 3. There they are. And then I want to add those two factors. So in other words, when I add those two factors, they must be the sum of the middle term. So positive 6 plus positive 3 gives me positive 9. Remember, it's 9a. So if I split this now up, I get, take this, there it is there. So I have positive 6a, positive multiplied by positive gives us positive. So I have positive 3a. And all I need to do now is just to simply drop the constant. In this case, if I drop the constant, the constant is positive 6. And our coefficient there is positive 3a squared. Now, when I collect these, or rather group these factors by factorization, I'll be putting these in the parentheses like that. This is a parenthesis, first parenthesis, and the second parenthesis. Looking at, or rather we now need to find a common factor. In the first parenthesis, we can clearly see that 3a is a common factor, so we have 3a, and then we have a, because 3a multiplied by 8 gives us 3a squared, plus 2, close bracket. Moving on to the next parenthesis, our common factor is simply 3, so we have plus 3, open bracket, a plus 2. Notice we have same identities now, same expressions. So now in this case, we just need to group these. So we have 3a plus 3. There they are, 3a plus 3. And also we have a plus 2. Remember, these are two identities there, multiplied by a plus 2. Now, we're not, appears that we are not done. It looks like we need to look at the second example because we need to factorize that fully. Now, moving forward, so factors of the first parenthesis, common factor, once again, is simply 3. So we have a plus 1 rather, close bracket, multiplied by a plus 2. Notice that answer looks like our first answer there, and that are the same. Okay, and then we did not finish this the second example. So with a common factor, once again, is 3, and we have a plus 1 multiplied by a plus 2. Now notice this, and that. In other words, these answers we derive at the same answer but using different applications. Our second answer looks the same as our third answer, and also looks the same as our first answer. In other words, we just show their different variations in terms of factorization. And then brings us to the end of this application. Thank you for watching. Please like, share, and subscribe to my channel so that I can create more content and more educational videos such as these. Thank you for watching. Don't forget to drop a comment below so that I can be able to identify certain pointers relating to these aspects of factorization and algebra. Thank you. Goodbye.